Hi everyone, welcome back to Learn Computing with Daniel Bullen. I'm Daniel Bullen, and today I have a video lined up for all you budding computer scientists and all you students out there. So we're going to do a dive into the GCSE Computer Science Theory paper by the AQA exam board. This one is a paper 1, and this particular paper is from the perspective of C#. So, but before we get started, if you haven't done so already, hit that subscribe button, ring the notifications bell so you never miss out on some of that tech-tastic content. So, let's get right into it. And I will also reveal my tips at the end of the video on how to approach a past paper question. I'm not going to read through the materials and instructions because an invigilator will read that to you just before you start the exam. Total marks is 90 and you've got 2 hours. So let's have a look at the first question. An algorithm uses a modulus operator that has been represented using pseudocode in figure 1. So line numbers are included, but they're not actually part of the algorithm. So the modulus operator is used to calculate the remainder after dividing one integer by another. So let's say you got 14 mod 3 evaluates to 2, 24 mod 5 evaluates to 4. So the first question is we need to shade one lozenge that shows the line number where selection is first used in the algorithm figure 1. So we need to shade one lozenge. So these are the lozenges. So if I was doing this, the first one that I would be shading away is actually going to be line 2, because that is where we're using the mod operator. So it's line 2. If you say line number 2, that's correct. Number 2, let's shade one lozenge that shows the output from the algorithm in figure 1 when the user input is 4. So let's go back up. So we got the user input. If I modulus 2, it's output I times I. So that's squaring, or we just output I. So the answer is actually going to, so if we say I is 4, 4 times 4 is going to be 16. So if we shade 16, that's correct. 1.3, shade one lozenge that shows the line number where assignment is first used in the algorithm. So, as we have seen, it's actually the very first line. That is where the assignment is. Let's go into part 4. We need to shade one lozenge that shows the line number that contains relational operator in the algorithm figure 1. So it would actually be line number 2. So line number 2 is where we got the if, the mod, and the then statement. And then the last one, which is 105, shade one lozenge to show which of the following is true about the algorithm. Process of elimination. So, algorithm doesn't have iteration. Algorithm hasn't got a named constant in this case, and it doesn't have a Boolean operator. So it's going to have a multiplication operator instead as one of the arithmetic operators. Okay? And then finally, 106 on that question. Figure 2 shows an implementation of the algorithm in figure 1 using C#. So the line numbers are included, but it's not actually part of the program. So the program in figure 2 needs to be changed so it repeats 5 times using the definite count control iteration. So we're going to shade one lozenge next to the program that does this correctly. So, out of the lozenge, we got A, B, C, or D. So, the answer, well, we don't want to decrement and we don't want to increment. So, D and C is out. If we have a look at B and A, we do want to do a for loop and we want to do inputs. And then we want to do if I modulus 2 is 0. Then we want a console dot write line, which is I times I, or we're just outputting I. But the key difference, if you have a look, we essentially want it to do it 5 times. So if you have one careful look, if you said B, you'd be wrong. Because if you notice, it's got a 6. Okay? If you have a look at A, it's got a 5, and we want it to do it loop 5 times, which shows that it's actually A is the correct answer. So in a question like that, you need to have a keen eye on this. And there we have it. Okay. Question number 2. We got figure 3. So it shows an algorithm represented using pseudocode. So that calculates the delivery costs for an order from a takeaway company. So we're inputting the total and delivery distance. Delivery cost is set, and we're doing 2 messages on minimum spend not met and delivery not possible. So if the delivery distance is less than or equal to 5 and the order total is greater than 0, then we're going into the elif. So if order's over 50, then delivery cost is 1.5 and we output that delivery cost. If it's over 25, then it's the order total divided by 10 times 2 to get delivery cost. Otherwise, we're just going to message 1. And if a delivery distance and order total not met, then it's just going to output message 2. So, figure 3, we need to complete the table. So, 55.5. So it's delivery distance less than 5, so that's a 2, so that's fine. So we're going to go if the order's 50, more than 50, then the output, if we actually put it in, is actually going to be 1.5. Okay? That's it. 35, we know it's equal to 5 this time. So that satisfies that condition. But the order total is going to be 35. So it's not going to be over 50. So instead, we're going to go into the else if block. Whereas over 25, so we're going to have the delivery cost equals the order total. So if you remember, so we've got the order total divided by 10, which is your 3.5, and then times by 2, 7.0, but they will accept if you just have a 7. But the correct answer is 7.0. Okay? Moving on. So we need to state how many possible values the result of the comparison delivery price could have in the algorithm figure 3. It's just going to be 2. You could write it in letters, or you could write the number 2. Don't need to spend much time on that one. Okay, let's say we want to state the most suitable data type for the following variables in figure 3. So the most suitable data type, so if we got delivery cost, that is going to be a real, which you can also have float, or you can have decimal. Doesn't matter which one. In message 1, which is the variable identifier, it would be a string, or you could just have str. But in this case, in the case of C#, it's just going to be a string. If it was str, it would be Python. But never mind that. Let's go on to the next one. So we need to state one other common data type that we've not given. So you can have int, you can have integer, you could have date, you could have boolean. They're the other common data types. Okay, number 3. So figure 4 shows a C# program that calculates car parking charges. So the user inputs the car registration and the length of the stay. So the program outputs the charge. So line numbers, it's not in the algorithm, so don't worry about the numbers. So this is the rest is the algorithm. So what we need to do here is write line 5, which is this line, where we concatenate the car registration with the string is not valid and store the result of the variable in a display message. So it's got to be stored in a variable display message. So the way you would do this in C#, it's a pity you're not going to have an IDE when you do this. So it would be string display message equals car reg plus is not valid. That, by using the plus in C#, when we're dealing with strings, is how we concatenate a string. Okay, so that is us altering line 5 in that code. Okay, let's get on to number 2, part 2 of question 3. Charge for 2 or more hours is changed to include an additional £2 fee. So we have to rewrite line 15 in figure 4. So instead of having charge equals hours times 2, what we will need to have instead, you can have one of two options. You can have charge equals hours times 2 plus 2. Or you could have charge equals 2 plus hours times 2. Any of these ways will get you a mark. Either one of them. So you're fine with that. Doesn't matter which order you do it. This is fine. Right. Number 4. So we got 2 C# programs in figure 5. They will output the value that is equivalent to adding together the integers between 1 and an integer entered by the user. So let's say the user has entered integer 5. Both programs output 15. So you've got program A and program B. So what we need to do with that one is we need to shade one lozenge to indicate what statements are true about the programs in figure 5. Right, that's time for the elimination round. Woohoo! So, shade one lozenge to indicate which of the statements is true about the programs in figure 5. A. Both programs are equally efficient. B. Program A is more efficient than program B. C. Program B is more efficient than program A. Okay. Ooh, what will I think in an exam? Let's have a look at the code, shall we? Well, I think I'm going to go for program B is more efficient than program A. That'll be my final answer. Ding, ding, ding. Drum roll. Bosh, it's actually C. It's actually C. So if you shade lozenge C, you're just correct. You won a mark. If you shaded one of the other two, they are the wrong answers. Wah, wah, wah. On we go. So it's actually C. Program B is more efficient than A. You might be thinking, what? But it's got a for loop though. True. Which is repeating. Yes. Can do that. That's got 6 lines. That's got 6 lines. But we don't need a for loop with more variables and more operators and an increment. All you need is enter a number, read in a number, num1 plus 1, and then times it together and then divide. That's all you need there. So it's doing the stuff that we need it to do. Okay, now what we need to do is say, okay, why did I pick C? Well, and that's a 2 marker. So it'll take a lot less time for the computer to execute program B, because fewer lines of code will be executed. Or you can have the number of calculations performed is constant in program B, but it's going to increase as the number input gets bigger in program A. So it's going to take less time for the computer executing program B, whereas in program A, the number input will get bigger in program A. So they will accept program B has fewer variables, so it's going to use less memory when executing, which is also fine. So, question 5. A programmer has started to write a program using C#. The program is shown in figure 6, which needs to generate and output 10 numbers, each of which is randomly selected. So, what number am I going to have this time? In the data structure called numbers. The program is called random class. Uses the random class. So if you got r.next08, that is going to generate a random integer between 0 and 7 inclusive. So one possible output from the finished program will be from 11 to 2, because that is what's in the array. Okay. So we got a selection here where we need to shade 2 lozenges to indicate the statements that are true about syntax errors. So the answer you would get, there are 2 answers this time, not 1, 2. Hence, 2 marks. Yeah, 2 marks right there for A. So syntax error can be found by testing boundary values in a program. Syntax error is a mistake in the grammar code. Ding! Correct. Syntax error is generally harder to spot than a logic error. And then we got D. Syntax error will stop the program running. Ding! Yes, it does. Example of a syntax error is trying to access the 5th character in a string which contains 4 characters. So, what are the answers? B and D. They are the correct answers. Okay. So we will need to remember this algorithm because the next part question will go into it more. So the program in that figure contains a logic error. So we have to identify the line number that contains a logic error and correct this line for the program. So you get 1 mark for saying the line number and another mark for saying a corrected line. So we know if we have a look back up here, you can see It's actually line 7 where there's an error. Why? Because you've got numbers count, you're just counting how many numbers there are. So what there should be in here is going to be console.writeLine numbers number. And that's it. Literally it there. Okay, what type of data structure is the variable numbers? Let's have a look. That is an array. Yes, array. That's an array. So an array is we can put lots of stuff in one go. So yep, if you say array, you bang on the money for marks. Or I should say you bang on the marks. Okay. A program is being developed. Number 6, a program is being developed that allows users to rate and review movies. Cool, I wouldn't mind watching a movie right now. A user will enter the rating out of 10 and a written review for each movie they have watched. If you could rate this video out of 10, that will be appreciated. But anyway, computational thinking skills are used during the development of any program. And one of them is abstraction. So, for those who've forgotten or need to revise abstraction, think of it this way. It's the art of convincing yourself and others that you understand something perfectly by ignoring all the mucky, messy details and complexities, kind of like pretending your room is clean by shoving everything under the bloody bed. It looks like a painting saying, "Ah yes, I see in the art this profound expression of existential angst," when you're really squinting at a bunch of colourful blibs and blobs. But hey, abstraction, you're basically making complex things look simple. That's all abstraction is. But if we want a mark, abstraction is removing the unnecessary detail. If you say removing unnecessary detail, that's a mark, bosh, right there. Okay, so I will give you a tip on answering. I will give you the tips at the end, so keep watching if you want to hear the tips. Okay, number 6, part 2. A user will be able to register, log in, and log out of the program. So when registering a new user, we'll enter the details before confirming their email address. So figure 7, we've got the design of the program, but we have to complete the decomposition of the program by stating what should be written in boxes A and box B. So yes, there isn't any room to... Oh yeah, there is. So A, we have a look. Movie rating program, register new user, enter details. You do this every day when you're signing up. Bit of common sense. And same for B. So let's apply some of our common sense. If you say confirm or enter email address, you're going to be bang on the money. Anything else, you're just being a plonker. Right, let's try B. Movie rating program. We're going to log in and we're going to what else? Think, what's the opposite of in this case? I would say log out. Those two will be correct. If you decided to say anything other than log out, then I only got this to say to you. Don't be a plonker all your life. You wally. You plonker. So if you say confirm in A and log out for B, ding, cushy. Done really well there. If you said anything else or put them in the other wrong way round, you plonker. But hey, if you've got confirm and log out, you're fine. You're on your way to marks. Ooh, number 7. So this is where we've got to write a C# program to check if an email address has been entered correctly by a user. So our program has to get the user to input an email address, get them to input the email address a second time, output the message match, and output the email address if the email address entered are the same, and output the message do not match if the email address entered are not the same. So we should use meaningful variable names and C# syntax in your answer. So this is saying to do C# syntax, not pseudocode, not code from here, not from there, not from over here. It's from C#. If it's not on C#, you're just being a plonker. But never mind that. So I am going to go on the longer lines because I like to think that's where the common sense is. So you would have string email console.readline. That's the first bit. But you're not just going to have string email, you're going to have string email 1 because we need to have 2 emails. Hence why we're going to have string email 2. And that's also going to be a console.readline. That is what you need there. So, and then what we need after that, so we've got the inputs, and then we got the 2 inputs, so we got those 2 bullet points down. Bang. Next bit, if. So we need if email 1 is not equal to, so in C# we write exclamation point equals email 2. And brackets. Then we have curly brackets, and then we're going to have console.writeLine do not match. And then we have a closing curly bracket. If you have an open curly bracket, you've got to have a closing one. Otherwise, it's going to say console.writeLine. We have a match. And I don't mean a football match. So, and then we're going to have console.writeLine. Email 1. And that's our code. That is our fully correct working code in C# worth 5 marks. So there's nothing more you need to say in that. Another way you could have done it, however, is you could have, if email 1 is equal to email 2, you could just change the code around. So that if it does meet the condition, it's going to output the console line match in email 1, otherwise do not match. So whichever way you choose to do it round, you can have the console.writelines in the opposite places, but remember to use the correct relational operator. So if it's equal to, then we can do match in email 1, else do not match. If I decide to keep them not equals, then we would change those console rights around. Okay? And that is question 7. Bosh, done. Ooh, number 8, another C sharper. Another C sharper? Can't handle the heat? Get out the exam hall. Okay. So we've got a C# program that calculates the value of a bonus payment for an employee based on how many items they have sold and the number of years they've been employed. So let's break this down. Decompose it, we must. So get the user to input the number of items sold, get them to input the number of years employed, output the value of the bonus payment. So if the years of employment is less than or equal to 2 years, and the number of items sold is greater than 100, then the bonus will be a number of items sold multiplied by 2. If the years of employment is greater than 2, then the bonus will be a number of items sold multiplied by 10. Otherwise, the bonus is nothing. But we should use meaningful variable names and C# syntax in our answer. So the answer grid is below. That contains vertical lines to indent your code. Yes, so you would need to indent. You put your code in the correct boxes. So, okay, text box I must have. So, let's break it down we must. And break down the code I will. Yes, and that's not one of my cheesy Yoda quotes, but hey. So, first things first. Get the user to input the number of items sold. So we're going to have a console.write. How many items? I don't know. How many items of my favorite thing? I don't know. There we go. Yes, not soy sauce, by the way. I can't stand stuff. I don't know how people do. But hey. Then we need an integer variable called items. Convert dot to int 32. Console.readline. Boom, 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 boom. If you have 2 open brackets, gotta have 2 closing brackets. How many times? Then we got the item. And then we need another console.write. How many years employed? And then we're going to have int years. Convert to int 32. And we're going to have console.readline. Open bracket, close, close, semicolon. Done. So we've got the stuff stored in the 2 variables. So that's fine. So we've got the items sold, years employed. Now we need to decompose how we output the value of the bonus payment. So if years is less than or equal to 2, that's the first bit. Then we're going to have if items is over 100. Then we're going to have console.writeLine, which is going to say items times 2. And after that, we're going to have else. And we're going to have console.writeLine 0. So that's fine. And then finally, we have another else. And finally, we got another else in there. Then else, we're going to have console.writeLine items times 10. So this is going to be our fully working code in there. So what I should have done was delete that. So you can see that this is what our code needs to look like. So that is one example of a fully correct answer there. You could also, so we go if years is less than or equal to 2, items is over 100, then it's going to go items multiplied by 2. Otherwise, it's going to be 0. it's less than 1 year, it's going to be items times by 10. And that, ladies and gentlemen, is our C# program worth 7 marks. On to the next one we must go. So, what we've got here now is we've got line numbers, so we've got in figure 8, in pseudocode. Not line 8, sorry. Excuse me. We've got figure 8, shows an algorithm represented in pseudocode. Substring will return part of the string. So substring 35, and then programming will return the string GRA. So we have to shade one lozenge to show the output for line 4 from the algorithm shown in figure 8. So let's go to line 4. Going to have name 1. So we need to look for the variable name 1. And that is going to be S. Because we need to find in line 4, name 1 dot 0 is S. On with the next bits. We need to shade one lozenge which shows the output of line 5 from the algorithm shown in figure 8. So line 5, so let's go up to line 5. Len names. So we're using the names variable now, which is going to be an 8. So the answer is actually going to be a B, which is 2. Okay, part 3. We need to state the output of line 7 from this algorithm. So the output is going to be Sarah. So if we go up to line 7, output var, so it's substring 0 to 3, so it's going to be SAR 0, 1, 2. Okay, now we've got 2 extra lines being added to the end of the algorithm in figure 8. Yes, the figure of 8. And I don't mean the 8 ball. So fill the gaps. So the output from the new final line will be the string Thomas Ra. Ooh, Thomas Ra, that's an interesting one. So we got var, substring, and then name 1. So it would just be 2 for Thomas, and then 4. 2 and 4, done. So we've correctly identified that as 2 and 4. So Thomas Ra, if you have a look, so you got Thomas, and up the 4, so 0, 1, 2, 3 and 4. 2, 3, 4 there. So it's Thomas Ra. Right, and then we need to output names. So we need, if we can correctly identify a 1, that's our mark. Output the name in index 1. And that is question 9 so far. Question 10. Figure 9 shows a subroutine represented using pseudocode. So you've got a subroutine, you've got A is n, B is 0, and we're repeating the div. A divided by 2 and B increment of 1, increment B by 1, until A is less than or equal to 1, and we're going to output B. So the div operator is used for integer division. So we need to complete the trace table. But we don't have to use every row in the table. So what have we got? So 50 That's going to be a 50. Second one's going to be a 0. So 50. So we are dividing that by 2. That's going to give us 25. And then b plus 1. So it's 0 plus 1 is 1. So we've incremented that by 1. 25 divided by 2. You would think, well, it's 12.5. But look, it's integer division. When we're using integer division, it's going to be whole numbers. So hence we're going to have 12. Then b plus 1. B is 1. 1 plus 1, 2. Right. Next one, we got 12. We're repeating. 12 divided by 2, 6. And b is going to be 3. 6 divided by 2 is going to be 3. And then b, we're going to do, b is 3. So b plus 1, that's going to be a 4. And then 3 divided by 2, it's not going to be 1.5 in this case. It's going to be a 1. And then we are going up to 5. So that is what we need to do in our trace table. And then the output is going to be a 6. The output's going to be a 5, sorry. Because that is the final increment. That is the final increment in B. So the answer is going to be a 5. And that will get you 4 marks. Right there. Trace tables is quite a tough thing to do, but if you read the pseudocode and study it, you're basically laughing. Okay. Now we need to state the value that will output for the subroutine call. The output for the subroutine call calculate. So let's have a look at subroutine call calculate. It's actually going to be a 1. So we have to write number 1. So if we were to type in 1, we're not going to get a mark. So don't be a plonker and write the word. You need to write the number 1. Okay? And then on part 3, the identifier for variable B in figure 9 was not a good choice. So it's asking us to state a better identifier for this variable that makes the algorithm easier to read. So if we remember variable B, it's just variable B. So what we could have done, we could have called that counter or total. But if it was me, knowing that it's increment, I would have counter. Purely because you're counting how many times it's going to repeat. Total is if you want to keep the total. So I would stick with counter. But that's just me and my personal preference. Or you could say my OCD, which I don't have, by the way. So don't make fun of that in the comments. But hey, each their own. Okay. In figure 9, we've got a repeat until iteration being used. But in figure 10, we've got another subroutine called calculate that will use a while and end while. So it's doing exactly the same thing, but we're using a while loop instead. So the repeat until iteration figure 9 loops until the condition is true. While end while will do it until the condition is false. So you've got 2 marks for this. We need to just describe 2 other differences in the way subroutines in figure 9 and 10 work. So repeat until tests the condition at the end. That's the first one. The end while, will test the condition at the beginning of the program. So if you were to mention those, that's 2 marks straight in the bag. 2 marks straight in the bag, bosh, there you go, happy days. Kushti. Ooh, 11 point. 11.1, no. Right, let's see if we're not quite on a home stretch yet. The size of a sound file is calculated using the following formula. So you've got size, sampling rate, times resolution, times seconds. So we need to calculate the size in bytes, numbers divided by 8. 8 bits. 8 bits in a byte. So the algorithm in figure 12, represented using pseudocode, should output the size of the sound file in bytes. It has been sampled 100 times every second with a sample resolution of 16 bits and a recording length of 60 seconds. The way I'm going so far, I feel like I'll be gone in 60 seconds. And I'm not just on about the film. But I'm not going to be gone in 60 seconds because I want you to pass. Hopefully get this question in 60 seconds. Subroutine called getSize has been developed as part of the algorithm. So we need to fill in the gaps in figure 11. You don't need to use all the items in figure 11. So we're using figure 11 to fill in the blanks. So subroutine getSize, we would need samp rate because that's not declared, and then we need res. Those are your two parameters. And then what we got? Ooh, how do we get sample rate though? I know. How about we just put size? Bosh. And then we will need size. Remember, it's divide by 8. So it's going to be size / which is divide by 8. Kushti. If you see parameters in a subroutine or a function, we will need a return statement. So it's return. And I don't mean return and a king or the mummy returns. So for here, you've got getSize, which we need to pass, which we need to call here. And make sure you write it exactly as it's written. And don't be a plonker for going, oh, I forgot to do a spelling. Do it. Do it exactly as it's written. Okay, 11.2. A local variable called size has been used in getSize. So what is a local variable in a subroutine? A local variable is only accessible within the subroutine. So it's only accessible in that subroutine. That's all you need to say to get a mark. Okay, state 3 advantages of using subroutines. You can develop them in isolation. Bosh, 1. They're easier to discover errors. Bosh, done, obviously. And it makes program code easier to understand. Or you can have subroutines, make it easier to reuse code. That's what I love about subprograms. You can just copy and paste code that you know is going to work, edit it a bit, boom, 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 bosh, program done. Bang, bang. So yes, subroutines are brilliant things. If you know how to use them properly, they could be your best friend. So I feel like they're certainly my best friends for some of the tasks we went through together. Right. Question 12, final one. Okay, this is not some analogy about recipes or how to get soy sauce in Marxies. But hey, figure 13 shows an algorithm represented in pseudocode. Developer wants to check the algorithm works correctly. So this is our algorithm. Three array indexes, and we're doing two nested loops. So if the array is j plus 1 minus it less than array with index j, then we're going to do the temporary, and then we're going to do array, which is array j plus 1 increment, and then we're going to declare this is our variable as temp. I'm going to end if n4 bosh. But guess what? Drum roll. Oh yes, trace tables. So we need to do more tracing and the tables. Ooh, I am so sorry that you gotta do more of this. Well, you don't have to be really. So yes, you're gonna do more trace table stuff. So, rather than moan about it, it's got to get it done. We must. So, I, obviously, is going to be a 0. J is going to be a 0. And the temp is going to be a C. So the idea is, we want to get this in order. So at the end, it's going to have A, B, C. And that's what we want. So, by looking at that pseudocode, we got 0 and C. So we know that's C. So it's going to be, we're in I, so that's 0. J is also 0, so it's less. So now we want the next one, which is less than 1. If that's less than 1, then we're going to change that around. So the J is going to be end up, basically you're saying J equals J plus 1, which means in a temp, that's going to be a C. Okay, so in there we will have nothing in I, 1 in J, and in the temp we're going to have a C. Okay, which means what we're going to have in here now is we're going to have B and then a C. So we have ordered those. So we've ordered those with B and C. So they've been ordered. So now what we need to do is we're just going to have a 1 in I, so we've incremented that up by 1. So we've incremented that by 1. J is back to 0. And then the temp is not going to be a C anymore, it's going to be a B. So we go back into the array, where we're going to have, in I, we're going to have A, 1, and then we're going to have C in 2. So we've got A right. Now we need to swap A and B. So we don't need anything in here. And 1 is a 0, so that's fine. So that is fine. So 1, 0 is B. We swap the AC. And then what we need after that is A, and then we're going to have B. Until finally, underneath J, we're just going to have a 1. So that is how we would do the trace table. Okay? Right. Last couple of questions. Home stretch now. Home stretch we're on. If you can't do it by now, oh, hurry, come on, stay awake. This is the home stretch. So we need to state the purpose of the algorithm. You can have 1 mark just for saying it's a bubble sort. Or you can have a mark which will say sort the values in order. Or you can just say put into alphabetical order, which is what this algorithm does. So the purpose is to put the letters in alphabetical order. Bosh. Done. Last but not least, figure 13 is being included again. So an earlier attempt at writing the algorithm figure 13 had different code for lines 4 and 5, so the 2 for loops. So we need to explain why the algorithm didn't work when value 2 was used instead of value 1 and 2 lines. That's because the algorithm will attempt to access an element in the array that doesn't exist. Or you could say the algorithm will attempt to use the index which is greater than the maximum array index of 2. Any of those will get you a mark. So I will get on with the tips now. So now for the tips. And as promised in relation to these tips for success. Bosh. You've got to read the question. Read what the exam question is asking you. Think about it. Read it again. So you are sure on the question's instructions. And then think about the core points that you're going to put in your answer based on what you've learnt, because they're going to be copy and paste the mark scheme. Those three are just in general, in exams in general. In the programming papers, like your paper, whether it be paper 1 for AQA, GCSE and A level, paper 2 for NXL, paper 2 for WJC, etc. Look at the algorithm and look at it, study it. Have attention to detail. So it's always important to have that keen eye on attention to detail. So it could be as little of a difference as a different number in a loop or a different relational operator. It can be literally anything. It could be as tiny, minute detail as that. But if you're not sure about anything, have a go, because you might get some marks after that. So if you've enjoyed my videos, please remember to click that like and subscribe button, and put a comment below the video in the description. I do have my online course, Introduction to Computer Systems, which is also below in the description. So I've got quite a bit to offer there. And so you have just watched a programming past paper for the AQA 2022 exam, which is a paper 1, which is the programming paper. So that was what you've watched. Okay, so I've provided you that walkthrough. So what you need to do now is also grab some past papers, give it a go, share this video, hit that like button, share it with your fellow coders, your fellow students, and subscribe for more content like this. As always, good luck, and thank you for joining us today on Learn Computing with Daniel Bullen. Until next time, keep coding, keep practicing, keep being awesome, and very good luck.